Hi, today I'll be going over an FRQ from 2011, question number 6. In the Calc BC FRQs, question number 6 is always a Taylor polynomial problem, so it's best if you get familiarized with them. So let's get started with this problem. For the first problem, it asks you to write the first 4 non-zero terms of the Taylor series for sine of x about x equals 0. And then do the same for sine x squared about x equals 0. For Taylor series, sine of x is the equivalent of this summation. If you want to see how I derived it, come over here. We know that the Taylor series of the function f centered at 0 is the following equation. As a result, we can use this to help us derive sine of x. For example, f of x equals sine of x, first derivative equals cos, and so on. Likewise, let's figure out what the function is when it's at 0. If this keeps going, these 4 numbers will keep repeating. So it will be 1, 0, negative 1, 0, 1, 0, negative 1, so on. Since the derivatives repeat in a cycle of 4, we can write the series as follows. So if you can see, every time we're skipping over the even derivatives because they equal 0. As a result, their 0 value takes them out from the polynomial, and we have this. This is the answer, and therefore, for sine of x squared, you just substitute x squared in. So this polynomial function equals sine of x, and sine of x squared is equivalent to simplify, this is, since the series for sine of x converges for all x, we can also write this as you have the first 4 non-zero terms of the Taylor series for sine of x, and you have the first non-zero terms for sine of x squared. I would say that this problem is relatively easy. In a school course, you would be usually advised to memorize the Taylor series for sine of x, cos of x, ln of x plus 1, etc. But then if you can't, you can always derive it and solve accordingly. So after you solve for the first non-zero terms of sine of x, which is worth 1 point, just plug in x squared into x and you would get the 2 points that would be given when you solve for sine of x squared. Next, they ask us to do the same for cos of x about x equals 0 and write the first non-zero terms for f, which was sine x squared plus cos x. If you had memorized what cos of x is in Taylor series form, then you would do. Otherwise, you can quickly derive it here. As a result, cos x equals. Now that we have the first 4 terms for cos of x, and we know that f of x equals sine x squared plus cos of x, you can take the first 4 non-zero terms from sine x squared and add them to cos of x. When you add this up, it would equal 1 plus half of x squared, which came from x squared minus x squared divided 2, and essentially the same repeats for the next 2 terms. Therefore, these are the first 4 non-zero terms of the Taylor series for f. If you nailed down what sine of x or cos of x is in Taylor series form, you wouldn't have any problem with b. Finding the first non-zero terms of cos of x is worth 1 point, and if you add the function correctly, it is worth 2 points. Just remember not to make arithmetic mistakes. The third subproblem asks us to find the value of the 6th derivative of the function. This is quite easy when you have the non-zero terms of the function that they're asking for. If you remember when I briefly described the Taylor series, you can see that whatever value the exponent has, the derivative corresponds the same. For example, at x squared, you have the second derivative of f at 0. The sixth derivative of f at 0 is negative 121. Essentially, they're asking for the coefficient of x to the power 6 in the Taylor series for f about x equals 0. Sometimes students may wonder where the bottom number comes in. If the polynomial has the same number in the exponent